Hello everyone, welcome back to my channel and another Unreal Engine tutorial. In this session, we will pick up where we left off and continue our introduction to Substrate Shading Model. Instead of focusing on typical substrate slab, we will dive into the material's root node, specifically its blending mode option. We will also explore how to create substrate transmissive and masked materials. By the end of this tutorial, you should be able to confidently apply substrate shading model to your static or dynamic meshes using the techniques covered in these two videos. Thanks for watching and let's get started. All right, let's start with anisotropy example for substrate materials. My substrate option is enabled through project settings. Remember, we talked about that in the previous session. So any material that I create is a substrate material. I'm going to go anisotropy. Let's double click on that. And I'm going to bring my material window to the screen so you guys can see it. First things first, we create a substrate slab and hold down Control, connect that from substrate slab into front material. All right, first things first, we need to specify the color and we need to specify the specularity. I'm going to create 3 vector nodes. One is going to be a white color, simply for my F0. And the other one is going to be a grayish color for my metal. Something like that goes into diffuse albedo. So nothing too special about this. You can see immediately we are getting some sort of a metal looking object, and I explained why and how to control the metalness in the previous video, but for now we are going to leave it as is. We need to deal with roughness, we need to deal with anisotropy, and we need to deal with second roughness and second roughness weight. You can see far more effective results every time you include secondary roughness with anisotropy if you're aiming for that type of effect. Now, in case if you don't know what anisotropy is, when you stretch the highlights in brass metal, let's say, you get the anisotropy effect, which is opposite to what we see normally, which is isotropy. So before I put any values for my anisotropy, I need to find a way to have roughness and my second roughness weight in one block and control it with one scalar expression. The way to do that is by using substrate haziness to secondary roughness. So I'm going to type in substrate haziness. And there's only one node, of course, under substrate helper. Fantastic category to give that and provide that for us. You can see even the names are matching. So second roughness. So it's a no-brainer. It's not too difficult to figure out where to connect this node. And this is a fantastic node here because it's got roughness, which defines how smooth or rough a surface appears. Usually you target value between 0 to 1, and 0 means perfectly smooth surface like a mirror, and 1 means very rough surface. And then we have haziness here, and this haziness is a godsend because that allows you to use this node also on transmissive material. What it does, it controls how lights scatter within the surface of the material, not just on the surface. So it gives a soft, diffuse appearance, almost like a frosted glass. It gives you that type of look, which you can also parameterize if you want. So the way that you combine these two, base roughness, haziness, and roughness, is by simply putting an add node. So add node, and all three can go in this add function node. Now this controls the roughness altogether. I'm going to perhaps bring a texture, so that allows us to see far better result. And of course, this is a scalar that can control all three if you want to. So at the moment it's 0. It means that all three values are 0, and we talked about this. 0 means perfectly smooth surface, like mirror. I can just ever so slightly affect that, and you can see the degree of haziness in our roughness value, which is absolutely beautiful. To intensify that, I can always use a multiply that goes to A, and let's actually bring in a texture. I'm going to go into my textures. I'm just going to bring a simple black and white texture. By the way, something worth mentioning: compress without alpha on, editor show final encode on, and sRGB off. It's a data map. We talked about this. You can pick a channel. Let's say R goes in here, and as soon as I do that, I see the effect in here. Let's put in a coordinate, very simple texture coordinate with multiply. So far so good. I think the value in here is a bit too much, multiplication. So 0.1 should do the trick. We want the values to be subtle. But how about anisotropy? Well, with anisotropy, we bring in a scalar and plug that in. The key to get anisotropy, and that is very important, is to go negative. If I go, let's say, negative 0.4, which is relatively a high value, we instantly see the highlights are starting to stretch. I can go even higher, something like 0.6. Keep an eye on the specular highlights. You can see how it's now stretched. Now this is a type of look when you're dealing with the surface with anisotropy value in its metalness. Very cool, at the same time quite easy actually to set up in Substrate Materials in Unreal Engine. That should do it for this chapter. Let's go to the next chapter and explore some other effects. Now we understand how anisotropy works. Let's really quickly take a look at the masked blending mode in Substrate. So first things first, I'm going to create a material, mm_masked, and I'm going to double click on it. And of course, I'm going to replace the Substrate UE foreshading with Substrate Slab, and holding down Control, connect, and get rid of this one for now. Cool. You may have noticed that we don't have opacity masks here. I have two textures. I'm going to bring the two so I can show you. I have this texture right here, and anywhere that is black, I want that to be see-through. So with normal, I guess we know what to do. So I can go easily, if I zoom back a little and move that up, I can go sRGB to normal, right? That's there's nothing special about it. I can have M to bring a multiply, bring in the coordinate and a scalar. Let's go 1.5 and connect those in to take care of the tiling. That goes in here. that can also go in here. So if I go and apply this material, I should have only the normals working. But what about the opacity mask? Well, the opacity mask is on the node itself, on the root node itself. So if I go from opaque to mask, we get that opacity mask right here, not on the substrate slab. And then from here, you can see that I'm getting the perfect result. What if I want to tint it? What if I don't want this default color? That's easy. A 3 vector to diffuse albedo will get the job done. So if I give it a color like this and go apply, and let's have a look at the result. And there we have our final result. And anywhere in my texture where I have black values, it's now see-through. See how simple it is. I love Substrate Materials. Working with it is just so much fun, and it's pretty easy to set up, I should say. All right, now we know how to do that, which was fairly straightforward. Let's go to the next chapter and talk about transmission and see-through objects, but this time that involves index of refraction. We're talking thick glass, we're talking diamond, anything with the element of refraction. Now we know how to deal with masked substrate materials. Let's have a look at transmission and transparent objects with IOR, index of refraction. So I am going to right click, create a brand new material, and I'm going to go IOR, hinting that I want to introduce transmission but with index of refraction, because right now in our masked material we're simply removing a value. There is no reflection or refraction happening whatsoever. So I'm going to double click and replacing this one with substrate slab. So let's bring that in, always apply that to the front material, and let's move it to the side. First things first, I want to give this glass a color. To get a color, obviously I need a 3 vector. I'm going to bring that in. Let's go with just white color. I need a degree of roughness, let's say 0.05, something very subtle. We want that to be super shiny. Of course, something that you can parameterize and change. Now, again, with the look that we're going for is transmissive, so we definitely want to bring in transmittance from substrate helpers. We did talk about this in the previous video. MFP goes into SSS MFP, and from here you can give it thickness if you want. That's not mandatory, but we preferably want to give this a color. Now you get a funky result right off the bat because Unreal Engine and Substrate's engine in general is very confused. It doesn't know what exactly you would like to achieve, and that's where we need to make some adjustments in our root material node. The first change is kind of obvious, especially since we did the masked one. You know that you need to change the blend mode from opaque into translucent gray transmittance. Now we get something, but this is more like an air with a really weird halo around it. There is no refraction happening, nothing. And that's why you need to go and make further changes to this node. The first change I would like to make is to go and settle on a good lighting mode. You almost always, every time you deal with translucency and transparent objects with index of refraction, you deal with these two: surface, translucency, volume, and surface forward shading. Now, surface translucency volume focuses on lights being scattered within the material, which is very close to what we want. And it's appropriate for scenarios where you need realistic looking translucent material that interact with lights. What about surface forward shading? Surface forward shading is a shading model that focused on forward rendering, hence the name forward shading. And the functionality is it calculates on per object basis instead of per pixel. What does that mean? It means that you not only have precise control over transparency, you can use it in environments where performance is a priority. Perfect for virtual reality or even mobile platforms. So I noticed that with forward shading, you get speed and quality. That's why I'm going to pick that. Doesn't matter which one you pick, you're still not going to get refraction. You are going to get something very close to a bubble, a glass looking material, but it looks like a very thin glass. I'm going to enable screen space reflections just to prep for it. And in here, you need to scroll down, very important, and enable refraction method. We have index of refraction. Now we're talking. As soon as I do that, look what gets enabled. Index of refraction on my root material. And it accepts a value. Perfect. I guess from this point onward, it's easy. All I need is a scalar value, which you can also parameterize for your material instance, and just plug it into index of refraction. 1.33 is water. Why don't we start with that? And I should be able to see a breakup in lines. If I look, have a look at this line right here. See how it breaks up as soon as the light enters the material? You can intensify that by going to 1.5 based on the type of liquid that you would like to get in terms of the look, and you can sort of intensify the result or have a very subtle result. But the important thing is you now have refraction, physically accurate refraction. I'm going to go apply. Let's plug that into our static mesh, drag and drop, and indeed we are now getting refraction. You can see how things are distorting within the geometry. You still can give your substrate slab a specular profile if you want. So I have one ready. If I choose that, it kind of tints the specular ever so slightly, like that. So I can sort of put that into practice. You can change the degree of refraction if you want, increase or decrease the roughness if you want, and get slightly different look. So that's a quick look on how to set up your refraction within Substrate. Let's move on to the next chapter. Now we understand how to deal with index of refraction and transparency in Substrate. Let's talk about subsurface scattering. We hopefully know by now that subsurface scattering simulates the way light penetrates the surface of a translucent object. The light scatters beneath the surface, and each ray goes into different directions, cause subsurface scattering. This effect is crucial for rendering materials like skin, leaves, milk, wax, and even marble. The first couple of steps are quite similar compared to other materials that we've made. So I'm going to go with the material Subsurface. I'm going to give my surface an albedo color. So holding down 3, let's go with white. We can always change that and parameterize that. Goes to diffuse albedo. And let's give a roughness a value. I'm gonna go and plug that in, and let's go with something low like 0.2, although you need to do some research on your material. You know, the roughness of a piece of marble is very different to roughness of milk, for example. Now, there are two properties that I would like to address in here. Subsurface scattering MFP, and that gets usually a 3 vector constant. So constant 3 vector. And let's give this a color. Although I usually target one channel more than others, so maybe 0.2 for blue and something really subtle for green, and even lower for red, something along those lines. And I'm going to give that a degree of anisotropy. So selecting the 1 on my keyboard to create a scalar, go to SSS, phase anisotropy, and I'm just going to put 0.1. So that's basically a default structure for anything with subsurface. Now, a couple of things. The first one is if you want to have subsurface on thin surface, you need to tick that. And also it helps if things are double-sided. And as soon as you tick is thin surface, the subsurface thickness shows up. The default value for that is 0.1, but you can always increase that with a scalar value. So I'm just going to click 0.0001. So this is really thin, and apply that to your surface thickness. If I apply and look at my static mesh, you can clearly see the effect of subsurface scattering. So that's the first bit. The second bit is you might ask, where are the settings for subsurface? How can I fine-tune my albedo? How can I fine-tune my mean free path, scale, and intensity? And those type of properties come in as subsurface profile. So right off the bat, you're not going to get much. That's a very typical look, substrate, subsurface look. If you want to have access to more properties, you need to create a profile. Very similar to specular profile, you right click, you go to material, subsurface, profile, SSP _ subsurface. If I double click, we have so many properties to choose from. Now, where does this go to? Onto my substrate slab. So I'm going to click SSP, our profile, pick that, and as soon as you pick that, you can actually see the effect on that on the surface. If I save and go in here, you can increase the world size scale, which is cm, if you want to completely wash out the look of the surface. So 0.1, if I change it to 5, all of a sudden we barely see any corners. It's very waxy looking. And you can go into mean free path color, change the color, even change the intensity and the value of the color, and give it mean free path distance. And as I go through this, we sort of lose shadow in around the areas that you expect ambient occlusion and shadow. So look at here, if I put 10, we barely see anything. If I dial it down to 0.1, we can clearly see the effect of lighting. So 5 compared to 0.1, 5.1. So that's basically, in a nutshell, how you set up subsurface scattering in the substrate model inside Unreal Engine. Let's go to the next chapter and explore even more substrate materials that we didn't get to cover in the previous tutorial. Now let's talk about Fuzz in Substrate Material. We never had a chance to talk about Fuzz, as it can be a very different type of shading model that simulates the appearance of tiny fine fibers or short hair, which you often find on surfaces like fabrics, like velvet, or even skin. In some other DCCs it's called sheen, but in Unreal Engine it's called fuzz. So let's see how we can create that type of look. As usual, I'm gonna go and create a material, mm_fuzz. Let's assign that to our static mesh, and let's double click on that. Now that's where we are going to kind of recycle the knowledge that we have from the previous tutorial and bring some of the familiar nodes as there are so many similarities between getting fuzz and getting some different other looks that we've already explored. For the color or diffuse albedo, I would like to bring a texture. So if I go into textures, I have this blue pattern here, which I can bring. I believe it comes with its normal map. I'll bring that one as well. And let's plug that in instead. I'm going to very quickly create a coordinate. So I'm going to give it something like, I don't know, 10, and plug that in into diffuse albedo. And that also can go into my normals. Let's just plug that in into normal. You see what type of look we're getting. Let's go here. It's not too bad, but I really would like to intensify the normal. So what I'm going to do is just a simple flatten normal function to push the normals ever so slightly. I'm going to go and create a simple constant and perhaps push that just a little bit, something like 3, so the bumps are more prominent. This is by no means mandatory. I'm just doing this to give you the simulation, the type of illusion of getting more fuzz, basically. So the fuzz attributes are in here. We have fuzz roughness, we have fuzz amount, and we have fuzz color. The roughness of the fuzz, the intensity of the fuzz, and of course its color. To create fuzz, you need to have a soft, diffused look. We always prefer to give something to these guys for F0, F90, and roughness. So for now, I really don't know what I'm going to specify or set for these values. For now, I'm just going to set those to 0, but if we need to adjust those, I'm going to certainly adjust them. The reason I'm going to give them 0 for now is because, well, some of these can be produced using these 3 properties. So for fuzz color, that's perhaps the easiest one. Let's give this a type of color, maybe an orangey type of look. That goes into color. For the amount, I'm going to use a scalar, maybe something like 50, and bring the amount here. And as soon as I do that, you can see I'm starting to get a little bit of a different color, I would say, around the static mesh. And this is quite interesting because it simulates what usually F90 simulates. If I go and apply and have a look at the result, you can see we're already getting a little bit of fuzz in, but perhaps the trickiest value to set up would be roughness. Now I am going to recycle what I made in the previous tutorial, this set of nodes right here. Absolute world position, object position, go into subtract, using object bounds to divide the outcome, and then constant bioscalar, which is like a filter, saturate to clamp it, and picking only one value, which in this case is the R channel, and connect that into our roughness. If this setup looks a bit alien to you, definitely check out my previous tutorial, and I will thoroughly explain what each node does. So by setting up our roughness, you can see now we have fuzz, and if I go and check my model, you can see that the way that the light diffuses looks very different. Now from here you can change so many things. I can go in here and perhaps give this F0 going here. Just to see the light contribution, I can make this blue so it looks very obvious when I assign F1, and you can see right off the bat I'm getting a slightly different result. You already know that if you want to remove the metalness, you need to bring substrate metalness into SSMFP, so we are not going to discuss that, but basically that's the extent of what you usually do. I can intensify this to get a slightly different look, less metallic so to speak, and take it from there. And then we get kind of more fuzz coming in. Now if I have a look, I get a little bit of F0 with fuzz as my main material. If you don't want to have textures, that is totally fine as well. So I can perhaps hold down Alt, disconnect this, move that aside so the tiling only has an impact on the normal, and instead introduce a type of color and assign that into diffuse albedo. These are some of the decisions that you can make to fine-tune your work and get it closer to what you want. So in a nutshell, in like few minutes time, that's how you set up fuzz in Substrate shading model. That is it for part 2 of Substrate Materials in Unreal Engine, the Beginner's Guide. I hope these tutorials have helped you grasp the basics of this incredible shading model. It's always a pleasure connecting with you, my amazing audience. Feel free to share your progress in the comments and let me know if you would like to see more advanced examples of substrate materials. As always, thank you for your ongoing support. Until the next video, see you guys later.